Hello students, Ms. Slyman here with some notes on Unit 1, Section 3, and this is our last revision, and now we're thinking about systems of equations that have quadratics in them. So if I've got a system that has a line and a quadratic, that means that, well, I've got a line, so some sort of line, and a quadratic. So let's put in a quadratic. And of course, if I draw them this way, then I've got two solutions. There. But maybe that line was down further and looked something like this. In that case, we say it's tangent, and that would have only one solution. So this case is tangent. And tangent means touches at one point. So these two lines are tangent, and more so tangent is when we're just barely grazing. So two lines that intersect, something like this, we would not say that those lines are tangent to each other. We say they intersect. And then, so we've got still one more scenario, and that scenario is that our line could be completely under our parabola, and in that case, we would have no solutions. So we'll either have two solutions, one solution, or no solutions. And of course, you should be making connections in your head to the discriminant, because when I go to solve this system of equations, I can solve it with substitution. Both of them are equal to y. So I can replace this y with my mx plus d, set them equal to each other, and then I've just got a quadratic. So I know with the discriminant whether I'm going to have two solutions, one solution, which automatically implies tangent, or no solutions. All right, let's look at the second case. If I have two quadratics, well, two quadratics, we're going to have a few different scenarios. I could have one quadratic face up, one quadratic face down. Again, two solutions. I could have one face up, one face down. It doesn't have to face down though. To have just one solution, I could have also had something like this, a narrower one inside. So in this case, my one solution is if they share a vertex. And then no solutions is definitely going to be if one points up and the other one points down and they are below each other. So again, we've got two solutions, we've got one solution, or we have no solutions, no real solutions, I should say. And again, that's because when I use substitution, I equate ax squared plus bx plus c equal to px squared plus qx plus r. And again, I've got a quadratic system, and I could use my discriminant to tell me what's happening. If I have only one solution, it means they share a vertex. That's an important thing to note. So that's the start of our notes. That is the start of Part A with our Unit 1, Section 3 notes.